including Paulina Chmielarz. I know I've already butchered it. I would have thought the Chinese names would be the ones you'd trip over, but who is Senior Manager of Logistics Planning at Qoros Automotive. Qoros, of course, I'm sure you've all heard of by now, one of the newest, if not the newest, brands to come on the market in China with a new plant. So Paulina obviously will have a lot of interesting insight for us in terms of logistics and plant design and innovation. So we'll have a presentation. We'll start with Paulina. Then we'll hear from Songping, who is the president of the FAW Group 9th Institute in research and design around plant and logistics. So again, a very, very interesting presentation there. And then finally, last of course, but not least, we'll have Mark Pappenhoff from DB Schenker. Sorry, my holding slide is flashing in and out. I couldn't read it. Who is the Global Business Development Manager. And then we'll have plenty of time for Q&A. So I'd like to invite Paulina now to the stage.
Thanks a lot. Thank you very much, Christopher. Hello and welcome. My name is Paulina Chmielarz. I'm from Qoros Automotive. I'm Senior Manager for Logistic Planning. I'm responsible for all advanced planning and engineering of our supply chain for our first plant of Qoros and also for all of the general planning activities that we're doing in here. I will give you a short introduction about our company, about who we are, about our very small and short history that we have until now, and then I'll give you a couple of insights of what happened with us throughout those years in terms of the supply chain. So how it all started from a small conversation in a teeny tiny office to a plant with the whole supply chain with more than 120 suppliers of direct materials and equal to that equipment and system. So starting with our company in general, we are an international car company with headquarters in China. We consider ourselves international. We plan and design product for all over the world. We are not China specific, but we do have headquarters and we plan to stay in China. Our product is all focused on design, on the engineering and the safety, as you will know. And it's all about creating a different car model, different cars and different product for new, young, modern people, urban people who are all about services, IT, communication, and connection to the world more than there is in average right now. For our product, we select all international and best technologies in terms of manufacturing as well as engineering. And we also choose all the best class suppliers and partners all around the world. So we can proudly say that all the international suppliers that right now support all the other OEMs also decided to support us, and we are very proud of that. And we have an all-new, brand-new greenfield facility. So we're not only a greenfield company, but we're also a greenfield plant. The first one ever for us in Changshu. This is around 80 kilometers away from Shanghai, in Suzhou, in Jiangsu actually, province. All new facility, all new equipment, all new people, everything brought together within a couple of years. And right now we are in serial production and we are actually already selling cars for a couple of months, which I will share with you a bit later. In terms of our facilities, we consider ourselves international, and we have facilities both in China as well as in Europe. In China, we have 3 facilities, our headquarter plant in Changshu, but also 2 facilities in Shanghai. The first facility in Shanghai is in Liujiazui, where we have our operations center, and where we have all the marketing and sales and the typical HQ people. But then also we have a second facility in Shanghai, which is our tech center. It's also in Pudong, and then where all the testing and engineering and the hard work is happening. Besides that, we consider 2 locations in Europe as well. Our design center, QDT, is based in Munich. Our design chief, Gerd Hildebrand, if you know very well the car from BMW Mini, where he used to design Mini, now he designs Qoros. And we have a very big collaboration with Magna Steyr in Graz in Austria, where hundreds, if I would like to say even thousands of engineers helped us in partnership to develop the car. Our short history, we started the company in December 2007 when formally CQAC got the license to produce the cars and to business license and became a company. And shortly in 2008, we established our office in Shanghai, here. In 2011, in October, our first prototypes, offline built, a batch of 60-something cars, made completely from scratch, designed and developed, started the test. And within 1 year from that, in November 2012, we built our first production tryout car from production line in Changshu plant. One of our biggest success is our debut at Geneva Auto Show, where we are very proud of what happened in there and how much attention we got in Geneva about our product. Very shortly, it followed with Shanghai Auto Show. For those of you who were last year in Shanghai Auto Show, you know how much crowd it was. But I was there personally, and I could barely even see the cars that every day I'm watching in the plant, which was very successful, and we are very, very happy about it. At the same time, we already built 100 cars in the plant, all from production lines, all from the facilities, equipment, and people who were brought together for the first time. Later on, by September 2013, we got our 5-star Euro NCAP rating, the safest car in 2013, and second best car, second safest car in the world since history of Euro NCAP. All of that within extreme effort from engineering and quality in a strive to get this car as best as we can. And all of the new people and all of the first-time testings, and we got such a great achievement in there. 2 months later, in November 2013, less than half a year ago, we opened our first dealership in Nanjing. Right now, we have already 20-something of them, and we keep developing this year. We are right now fully operational. The plant in Changshu is running. We are operating. And all of this strive for the last 6 years, actually 5 years, has been all about getting all of this stuff done together and bringing all of this really into operations. For today's discussion about the supply chain innovation, or actually the plant innovation, I would like to give you a short description about what happened with us actually in 2010 and how from the startup, from a company that had like 30 people in 2010, we ended up with more than 2,000 right now and with this huge production. Well, it all started with me and Executive Director of Manufacturing and Logistics, Fritz Maillot, in December 2010 in a small office, a tiny conversation which took around 4 hours when we said, who do we want to be in terms of supply chain? And at that time, we took together everything that we know and everything we know about the company and also about the market and about the country that we are about to start our operations. And we put this stuff on paper, and that's how step by step we ended up with actually producing the cars. I will tell you about all single actions and all single decisions that we've took, which are for us innovative and for us as something different that happened or happens usually. And I will show you a couple of results, what it came through, so you could see how from a conversation 4 years ago to what we are right now, how it actually translated into where we are. So first of all was the vision. When we looked at the portfolio and the plans of Qoros, we saw that not only we will produce cars for Chinese market, we will also for European market, and for a couple of others also all around the world, and all of that out of the facility in Changshu. Then what we saw was the fact that for every 6 months, we're going to get a launch of a new car. Every 6 to 8 months, a completely new model or a completely new derivative will going to come into the plant, and we have to cope with that. This meant for us changes every day. Day after day, we knew that we're never going to just sit down and make standard operations, that we're going to constantly live in changes. So our base thing, the first word that popped out was responsiveness. So we said it has to be our main objective, not only in the demand, because what was so special, different about us was that we didn't have historical data. We didn't have the market data about how our models happen all around else in the world. We had to invent everything from scratch. So we have to be responsive to our demand, no matter it goes left or right, or all we know is that marketing would give us a forecast, and it will definitely change. So how are we going to actually prepare ourselves for that? And responsiveness was the obvious thing. Then responsiveness of the supply chain had to translate into the plant. We had to be sure that the plant has to be able to swap, launch, and produce multiple models for multiple markets at the same time in the same plant. And we have a fixed facility. And what are we going to do about it, and how are we going to prepare the supply chain for that? That then translated into the information. What does it mean for us? Do we go low automation, high automation? Do we actually say, let's start manually, let's start from Excel, let's do this and that, or we go full-blown IT systems that we probably won't be even able to operate? But we knew that we need to have real-time information, because having a launch every 6 months we need in supply chain to help ourselves from the data. Then, in all of that view, and imagine a greenfield company, greenfield factory, 100 suppliers that will work with us for the first time ever. We will have to bring all of this into one time at one launch, and we're going to have to cooperate. Not only direct material suppliers, also the equipment suppliers, the ones that do the facility. And how are we going to do that? From supply chain perspective, we said we have to be totally transparent. Suppliers have to know what we are doing, and when we have an issue on a day or not, and they have to know, and they have to be in constant contact and communication with us. And in the end, it's not only, first thing is the communication, but also then the assumptions of what our cooperation should be. So the next step was not only that I know who to talk to with the supplier, and I every day talk with him, but we also both had an agreement on the way that we're going to work together. And based on this discussion and based on this vision of what we need to do, we then went a step down, and we went into the strategic decisions and the single actions. I will tell you today about the actions and the decisions that we've made, both from the inbound side as well as the in-plant material flow. And for both of those cases, I will give you just a couple of examples, which for us were the most crucial and most innovative from our perspective. So first of all, from the inbound perspective, we said plant location is the key to success. We are small. We are literally not existing on the market. None of the suppliers will, first of all, looking at us, move directly where we are supposed to be. So we have to be in an area where industry already exists, or at least exists partially. Decision on the plant to be built in Changshu made it made a very big benefit for us. It brought a lot of help of all the suppliers that already had established processes all around the Changshu area. Second of all, we said that we have to support our suppliers if they want to localize. So even if they are in Shanghai or Nanjing or everywhere around, and they want to come to Changshu, we as Qoros, we want to help them. How did it happen? We talked to all of them. and we gathered the data. And we said, these suppliers don't want to move. These suppliers want to move, but they only want to do warehousing locally. These suppliers want to do little value-added operations, and these ones want to do whole-blown production strategically. They want to set up big facilities. And this is how we ended up with 2 supplier parks. We said the Changshu Economic Development Zone and the local government there showed us that there are 2 possibilities. And then that's how we as Qoros started talking in those trios between us and the development zone and the suppliers. And we said, this is the first thing. If you want to make strategic decision to build your facilities in Changshu, this is the area for you. And Qoros supported and the government supported. But then there were suppliers who said, okay, I want to localize, but I don't want to build facility, I don't want to build land, I don't want to tie myself up for 100 years. And this is when we, as Qoros, negotiated with the local development zone, and they built the buildings. They built standard buildings, and they built specialized buildings. And this is what took down the risk of those suppliers, and they were more willing to move their production to Changshu, at least for the final product. Then, having the plant and having the suppliers nearby, then we said we have to standardize our entry point to the facility. How are we going to transport? Of course, we have the gates, but are the gates enough? Is this the only thing we want to do? And then we said, no, what else can we do? Can we have a conveyor? Can we have something else? Can we have a bridge? Can we not drive on the road? Because if you know that not driving on the road means that you can have non-standardized transport equipment, that you can have special trailers, that you can have some stuff that is so customized for you that, first of all, improves your operation, but at the same time, takes you to another level of how fast you actually can deliver material to the line. And that's how we ended up with tunnels. Tunnels for body shop parts suppliers, tunnels for GA parts suppliers. Then we went into the gates. How many gates we need, how many docks we need to have in the plant, and what a dock unloading means for us. And this is where Qoros made strategic decision that we are going one standard truck type, which means side unloaded trucks. 99.9% of trucks, because there are some open platforms for chemicals that cannot be closed, otherwise, explosion happens. But when we said we want to have the fly wings, and this means not only that we have shorter time of loading, unloading, because we can load, unload from both sides, but we also can have standard docks. We don't need to have rear unloading. And that also means that our trucks are smaller, which means we do it faster and we don't need to do such a big warehousing. Then, having all of that, we said we have to standardize with the supplier. We started discussing and we created a standard template of what is the transport method, what is the packaging type, what is the delivery frequency, what is truck type, communication type between the two of us. And all of that standardization then helped us to gather the data and then either re-engineer the inbound supply chain or re-engineer the material flow in the plant, so we have one thing. We don't have a separation. Here is my inbound with my gigantic warehouse, and here is my plant which connects with the warehouse. This is our overview of the plant. You can see in here all of the flow. Here is a mini plant on the north of the plant when all the sequencing suppliers are holding on. And this is where their small facilities between 2,000 to 6,000 square meters is located. And we have direct internal road to control the GIS transport, so no on-road transport. Here is our plant, and here also you can see this is the tunnel 2 that already exists and is in use with the stamped part suppliers, through which we transport material with special taggers, with non-standard trailers built specifically to match Qoros racking. Here is the second tunnel, which is now started in construction. When we will need the second part of the logistics center, we will put it in. on the south of the plant, the supplier park is also building up some suppliers for general assembly for the other parts. And then we went to plan material flow. It was 2 parallel activities when we needed to make strategic decisions. And then in the plant, having in mind all the products, the models, and having one facility, what are we going to do about it? And then, yeah, from all the varieties of the methods what we can have, there are standard in the industry, all the sequencing, all the Kanbans, everything, what do we want to do? Do we want to investigate one by one? Do we want to match ourselves? Or we are going, this is the lead and that's it? And this is where we made very fast and very big decision. We are going 100% kitting. Right now, in the total general assembly, only 12 parts is on Kanban. Everything else is kitted. It means that we can swap models, change models, produce in 100 flexibility on the line, and operators barely can recognize that they are building another model. They just pick parts from the box. At the same time, we said, okay, this is the method, this is what we are going for, and what's next? Strategical equipment sourcing. What equipment do we want to have? Because if I, 3 years ago, collected all the catalogs from all the possible suppliers that are there on the world, well, I could choose forever, but I need to choose the type, and not a type of a forklift, but are we going forklifts? Are we going tow motors? Are we going platforms? And out of that, we said, we are going all mobile. We want a very fast exchange the material on the line. We want to deliver fast, and we don't want to deliver with the forklift. And we want to give the ability to the operator that he can slightly, even on his station, like in body shop, modify his rack 2-3 centimeters left or right if he needs to, that he doesn't have to wait half an hour for the forklift to arrive if needed. And then come out the packaging standards, all returnables. Right now, in total plant, we have 43 materials which are in expendable packaging. All the rest is in returnables, and we work with every single supplier to bring it in the quality and the excellence and in the operations and the exchange of the containers as best as we can. Out of all of that, the plant, the methods, and the equipment, it came time for the IT systems to pop out. And there's a gigantic palette of IT systems. And we could have choose again for forever. What was extremely important for us were 2 things: the functional attributes of the IT systems and the technical attributes. But not only how much I like it, how much functions there are, what can I do around it, but we came out from the other side. We said, what are my business processes in supply chain? And let's map first the business processes before we touch the ITs. Because if I touch IT first, then my business processes will never exist, and I will constantly play around the IT, and then it will just generally not bring us big efficiency as it should have. So we mapped we mapped the business processes, we had all the maps, and then we started searching for the IT. And then it came much faster. And I have to tell you, from all the IT implementations that I led throughout the plant, not even one failed. All of this through ERP system, WMS, portals, SPS, EPSs, everything through manufacturing execution system, through PLM that we are connected with. Every single thing came in time because we knew what we expect from our IT systems. And it was not always about choosing everything in one platform and everything in one supplier. It was about having the balance between what do I expect from IT system, but also how complicated it is for me to put it from the existing supplier or bring in a new one. Is the interface available or not? Is it automatic, or I every day have to upload, download Excel file? What is my master data model? It was extremely important for us to keep a unified master data model throughout all of the systems. That a rounding value in WMS means the same thing as rounding value in SAP. And at the end, and across all the projects and all the implementations in the plant, It was always about the endpoint, about the implementation buy-off. What we did from engineering perspective, engineering the supply chain, it was not only about having, oh, this is it, this is on the paper, these are the drawings, somehow it will happen, somehow it will get worked. It was about going down to the shop floor and to the stations with the people that are supposed to operate this and making sure that they are doing this and training them. And then asking them for the buy-off. Does it really work? Couple of examples of our equipment on the line. First of all, you can see here all the kitting systems. You can see here the prototyping of the kitting system. Here is already on the tryouts on the line. You can see here all of our fleet of mobile platforms, fully adjustable in here. You can see that we can go left to right. We can adjust. We are not totally fixed. You can see all of our metal racking in here, developed with our suppliers. And one thing that I just would like to mention in here, in which we had a lot of fun, but also it was one of the challenges, all the non-standard single cases, single things that we need to take care about in the plant that normally you just forget. All of the chemicals, all of the jigs that you have to return from general assembly back to paint shop, all of the labels, the bags and everything, which in a normal plant launch, you usually put them on a lower priority. We were a new company. We had to make sure that we're just not going to only have it on a lower priority, but we're also not going to forget about it. So it was a big challenge for us that if we have a standard process and all people know how to work in the standard process, that they also know the exceptions. And to engineer a supply chain for a VIN label or for a certificate paper that comes in once in a while and has to be specific, and to making sure that they use the same equipment, the same methodology for all of those non-standard special cases, that was a big challenge for us. So as a result, we are very happy of what happened in the plant, what happened with our supply chain. We are very grateful of what happened in our supply base, on all of the ones that cooperated with us throughout those tough times. We have above average responsiveness. We have very low risk against high complexity. We right now in the plant, we have in the Chinese model of the car that is already launched on the sedan is something around 200,000 variants possible to be produced. Of course, sales and marketing doesn't order all of them, but we are still able to produce them. We have a higher number and higher rate of equipment efficiency because the operator only assembles. He doesn't have to go away from the station, doesn't have to pick, make a choice. We have higher resource utilization. We have real-time transparent information, and at the end, we are safe. We are paying a high attention to our operations and that the equipment, the IT, that the operations are safe for the people. Thank you very much. I hope you enjoyed it. A couple of insights about us. At the very end, I just would like to say, this is our latest product, Qoros 3 Hatch, which will be premiered this Sunday at Beijing Auto Show. This is our second model, and we are very proud to say, I personally like it a lot, very European style. It got Red Dot Design Award. For all the guys who know and who don't know, this is a very prestigious design award, and we are very, very proud of it, and we like to show off for it. Thank you very much.
Thank you very much, Paulina, for sharing all of that with us. I think it's really fascinating to see the opportunity to kind of start with the supply chain vision and build from there. I mean, there's not too many places in the world where you have that opportunity to begin with, especially with a new brand and a new, starting really from scratch. So I think that was really interesting, really useful. We'll come back on more. I'm sure there'll be plenty of Q&A. But let's move swiftly to our next presentations. I'd like to invite Songping from the MMI Planning and Engineering Institute Research. Thank you.
I don't know how to. Okay, I change. Yeah, this is for change. Good afternoon, ladies and gentlemen. 大家下午好，我呢是来自一汽集团。
I'm from the FAW Ninth Institute for Research and Design, and I was given a topic by the organizers, which is innovations by new plants. Because this is an automotive logistic conference, so I'll be talking about the innovation in automotive logistics mainly. Firstly, about I'm learning to use this. Firstly, I'll be talking about our institute. We are the ninth research design institute. We got established in 1958. And once we belong to the Ministry of Machinery, among the 11 similar institutes, we do designs on factories, and now we belong to FAW. And our design scope includes the following. One is industrial technology design, and we also do civil work design. And civil work, it's a B+U design. And thirdly is design on production line. We have a branch to do that. And we got extension. We have a engineering design, including the contracting of projects. And in technology design, we are making efforts towards digitalized plants. We got 55 years of history, and we have different first-class licenses or certificates, and we have 3 design masters at the national level, and the provincial level we got 3 chief engineers, designers, and so we have got a very strong technological support, and we cover 30 different disciplines. We emphasize the needs of the clients to give us competitiveness. And let me get down to the theme of my presentation. Firstly, I'll be talking about the design of logistic systems or implant logistics. We emphasize systematic design, and we emphasize the production line, factory operations, logistics supply, and architectural design. And we always start with the assembly line, and we needed to design the workshop, the production line. We emphasize the 2 elements. One is the logistics along the assembly line. We need to consider different factors, including speed and also buffer zones, and also logistics off the production line, including the distribution and verification. And now we are mainly focused on the control of the processes, and we need to consider the equipment, the control on the equipment, and the diagnosis of potential failures. And we also need to consider safety so that we can satisfy the needs of the future. So we take the workshop as a box, and this box has to surround around a core, and that's our designing philosophy. First, then I will be talking about logistic program design and verifications. We needed to firstly design logistic process, and we needed to consider the status quo of logistics and distribution to find the weaknesses so that we can optimize the process. Secondly, we needed to consider the total area taken up by logistical programs, and we also have a software to do the demonstration. We do calculation of the area required by each by each logistic item, and we need to design the routes and the frequencies as well. And thirdly, we also need to do a simulation on the EM plant software to do the analysis and the simulation. Through the simulation, we can test whether the plan is in line with our original thoughts. And I want to play a animation. I do not know whether I can be successful. And this is a simulation. And so this is a simulation of a designed factory in Jilin. And so this is like a loading, unloading, and waiting area. And this is the area taken by each function, and this is the area, waiting area for items which have run out. The green area means the post verification area, and this is unloading area, which is being shown by red light, and red means occupied. Green means normal, and this is the sorted goods to be dispatched to warehouses, and these are parts by the production line to show the stockpile, and these small vehicles are for replenishment. And with the changes in the volume, there will be timely replenishment. And this is the store area, and this is a real-time picture of the store area and about the inventory. So we use the software to do the designing for logistic purposes, and they can satisfy the needs of the factories. And secondly, I'll be talking about integrations of different kinds. And I mentioned that we design processes, how processes can be in line, hand in hand with logistics. And this is Volkswagen's new factory in Fushan City, and this is a supply area, the just-in-time or JIT area. And so we designed this area closer to the exterior of the factory, and then it's also closer to the assembly line, like and also like the gears, transmission, and also framework is placed here, and we also SPS parts and also sequenced products are piled here, and so that they can get to the assembly line very quickly. And this area is a painting workshop, and so we put them into sequence, and this is for seats installation. So we put them into different places to avoid huge piles in one area, and this is a new design. And we also adopted the SPS supply method, so that we can realize the just-in-time. To realize the just-in-time or just in sequence, we need to consider the distances, and we also need to conveying belts. We call it aerial conveyors. And this is a factory for Volkswagen, the newest one for Volkswagen in China. And then I'll give another example of a Toyota. Also, it's a new factory, and in the Toyota new factory, you see that the production line is quite compact, and so we shortened the distances of different kinds for the car body. And for example, this is an entry point for parts. This SPS supply, and very rigid. The SPS all the whole way through, and this is the just in sequence supply methodology or GIS methodology. So these are motors and transmission, and this is interior parts piled up here, and I'm thinking like this for Toyota. This kind of a layout is very rigid. So for the assembly line, there is a high requirement on management because Toyota, they emphasize rigidness because they have production based on orders. And so the pace or the rate is within 60 seconds per unit. And so there is a high management level. This is number one.
Now I would like to talk about specific things, cases. As I mentioned just now, how can I go back to the previous slide? Maybe we can look at the second example then. The assembly lines, transshipments, the chassis, AGV is automated, and engines, AGV, assembly and transshipments. These are the newest case studies. The line was not, one line was not shown. I cannot go back to that slide. The whole floor is flat. There is no barriers at all. All those things that can be barriers are put in the air, not on the floor. So this is the latest concept of Toyota. In Tennessee, they have the newest plant there. And the concept I mentioned just now are all like this. The floor is flat, no barriers. And about the design within the line, for example, the mechanical transportation, design and simulation. I'm still talking about the total assembly line. Within the line, there are three. Previously, they are suspended in the air. But for new ones, it's a friction chain. Basically, all those adapted by Japanese companies, very small. The error rate is low. If there is a problem with one of the cars, you can just unload it, and the flexibility is much higher. And the latest production line we designed, it's a Volkswagen system, widely adopted. It's called EMS single rail transmission system, IHB in German. You can see the chain. It's very flexible, using servo motors for different products. You can adjust their heights very easily. For all Volkswagen plants, we are all designing them in this way. For example, in Foshan plant and in Changchun plant and in the new Chengdu plants, we are all using this method to design. It has also been extended to EMS single rail. It has been expanded to the powertrain. So you can see the evolution trends in the air. And about the ground, previously we call it slide. For example, previously it's skidding. But now it's using a big plate with very good flexibility, and the boxes, you can see the boxes. So we have grasped these technologies. We are using them, widely adopting them in the production lines. I'm sure the application of such technologies will benefit a lot the interline logistics. Now I would like to show you the simulation of the assembly line. Final assembly or general assembly production line. This is a simulation of the line. About the problems, For domestic design, basically they use two-dimensional CAD technology, but we are using 3D ones. And the errors and interventions for 2D, this is a problem. And third, the operations of the production line, we should optimize them based on historical data. It's not just the rate of operation of the production, but also the impact on the logistic platform. The previous problem was we cannot simulate the production line. Therefore, for future production lines, how to meet the needs for high rate of operations, we could not have effective evaluation. But if you did this before the design of the plant, it would be very good for future evaluation of plants. So in our JVs, we are doing this before production starts. That is the evaluation of the production line. And we are also using virtual reality to reduce the cost of design. The construction and installation cycle has been reduced. And we have also the considerations for buffer zone, mobilization rate, etc. That is to say, in this process there are a lot of buffers, but how many buffers? How large is the area? We can use this simulation to determine, for example, the platform, the impact on production capacity. I don't want to go into details. That is to say, we can optimize the planning design. After the optimization, we can address very well the problems of previous production lines. I cannot move it, and I think this simulation is too long. I don't think you're interested in this. Sorry. This is the Volkswagen final assembly line. Okay, that's all for the simulation. Next, I would like to talk about the function of logistics and production control system. First, at the corporate level, we are using ERP, very familiar to you. Now, what we are doing, actually, we need these two levels. One is hardware PLC, the equipment, and secondly, the most critical one is ERP lacks data support. And we need to add the production execution layer to increase the efficiency. Since you are specialized in logistics, so I'm sure you are very familiar with these things. Its functions are as follows. First, it should release information on production to visualize the management. And second, it should accurately collect data on production status and equipment to have real-time monitoring over the whole process, diagnosis and control. And thirdly, it shifts from passive resolution of problems to active, proactive management. Our attention is mainly focused on this now. This is major functions of the production control system and the monitoring of the stages of production line, output status, shifts management, type management, logistics information, and the end-on ropes. That is the monitoring of the status of the production line and the equipment. This is the logistics indicator system. You can see the unloading area, the pending departure area. I think the slides are going very quickly due to the time constraint. And the fourth part is about factory logistics combined with external environment. When we consider logistic planning, be it the production location, the suppliers of materials and Paths need to be within a radius of 5 kilometers. I want to skip the non-localized suppliers. This is phase 1 of the auto park area. And this is plant area, the spas area combined. And regarding logistics, this is the railway line, so we can set railway line, freeway, and the rivers, multimodal transportation. This is the planning for the industrial park. And second, about the Chengdu Auto Logistics Park, you can see within one zone, we consider parts and components, logistics organization of logistics. You can see 70% of the parts and components are within the logistics park. The radius is 5 kilometers. This is the Chengdu Auto Park. And the third plan is the Foshan Park. More direct, straightforward. You can see they are adjacent to each other. OEM company phase 1, phase 2, neighboring to them a large suppliers zone and logistics zone. The three are next to each other. So this is the plan for Foshan Park, Auto Park. And fifthly, I would like to talk about the cases on logistics combined with architectural design. This is a Volkswagen plant. The plant space, plant zone was limited, so they get the logistics to the outside area through sorting through the corridor to the workshop for general assembly. So you can see, so the general assembly use SPS, and the consolidation area has a large area, a lot of logistic personnel, but it is still very hard to reach the 60 seconds target, like Toyota. But this is architectural design. Another is the Toyota concept. In terms of the height of the plant, you can see some high, some low. About logistics facilities, they are 2 meters lower than the assembly facilities to save energy. And the floor plan also shows there is no hanging or hoisting in the workshop. It's a whole process optimization. This is the characteristics of Fengtian plant design. And other factors about Volkswagen's plants, its characteristic are as follows. First of all, the control center. Through the glass walls, the key control points of the several workshops, they can realize, visualize the management of key control points. And for general assembly lines, they are using hoisting to reduce or eliminate the barriers on the floor. About the logistics zone, the assembly line is basically adopting racking. However, for logistics, they use low-cost structure to reduce the cost of the facility of logistics. And fourthly, for post-production shipping, we use high corridors acting as a bridge, some spanning over a road, some in the form of underground tunnel to facilitate logistics and provide convenience for logistics. That's all for my presentation. I don't know whether it is of interest to you. I And I am not coming here alone. We have experts with us, experts in assembly lines. So if you have any questions, they will be in a better position to respond to your questions. Thank you.
Thank you very much, Mr. Louis. Judging by the number of photos being taken, I think your presentation was of interest to many in the audience. And obviously, what's allowed to be shared, we will send the presentations in a link to the participants of the conference probably sometime early next week, so just for your information on that. Thanks very much again for the insight into some of these plant designs and innovations in Volkswagen's and in Toyota plants. I'd like to move on to our next speaker now, since we're running a little short on time, and hopefully we still have some time for a bit of Q&A. But I'd like to invite Mark Pappenhoff from DB Schenker.
Ni hao. Good afternoon, ladies and gentlemen. I think this is the last presentation of the conference, I believe. So another service provider's presentation. I promise you I won't make it too long and too painful for you. Topic of this session is new plant innovation, and actually what I would like to present to you is how DB Schenker respond to that and show you what efficient and replicable solutions we have on hand in the field of production supply and just-in-sequence services, but also to give you a little bit of an overview of what we do in China. My name is Mark Pappenhoff. I work for the corporate head office of DB Schenker, being responsible for the development of our automotive solutions in the contract logistics division. Looking at the automotive supply chain, DB Schenker is involved in maybe nearly any aspects, starting at the inbound. Very good. Starting at the inbound, picking up at the suppliers the parts in milk runs, consolidating them in cross docks, bringing them finally to the plants, where we are also present with our just-in-sequence centers, SKD, CKD centers. And we're also involved in the outbound when it comes to finished vehicles distribution, but also aftermarket. But as said before, what I really would like to focus on a little bit now in the next minutes is the production supply aspect, so the just-in-sequence services. And this is what I would like to show you in a greater detail with a short video. Some of you may have seen it, some don't. I hope I can get this thing work.
The automotive industry has one of the most complex, highly developed supply chains, where a continuous, reliable flow of goods and perfect timing are crucial, and where every piece has to fit perfectly into the supply chain, accurately and without tolerance, reliable and sustainable. Welcome to our production logistics world. DB Schenker is one of the world's leading providers in production logistics services for OEMs and their suppliers. With more than 20 years of experience in the automotive sector, we have proven to bring maximum value to a long list of customers worldwide. One of these customers is Volkswagen Nutzfahrzeuge. Located next to their manufacturing plant in Hanover, Germany, DB Schenker Logistics Center receives and handles supplier components and gets them ready for the production line, non-stop, every day. Minute by minute, the production line calls off the required parts for the upcoming next hour of production. To meet those tough timelines, whilst keeping inventory carrying costs as low as possible, DB Schenker deploys state-of-the-art storage and picking technology. In the Hanover facility, we use an automated storage and retrieval system to store around 2,500 different small parts, whereby every 7 seconds a part is picked or put away. The parts that are required to be delivered at a predefined production sequence are picked up using pick-by-voice technology.
1, 3.
This technology enables our employees to use both hands to pick and pre-inspect every single part, filtering out any quality problems that may occur at the OEM's production line. This ensures error-free sequencing and time and cost savings. Our value-added services, such as light assembly of modules and customizing of specific parts, are postponement services, which reduce the need for holding a high variety of parts in stock. Here, for example, you see the assembling of a cockpit, being built from different supplier parts into one final module, which is then delivered just in time and just in sequence to the production line. All these services are empowered and enabled by our first-in-class technology and IT system. Through interfaces to different Tier X suppliers and to OEM systems, our warehouse management system, SAP Automotive, ensures efficient order processing as well as VMI stock visibility for all the involved parties. Our fully flexible IT platform allows fast expansion of the supplier base at any point in time. Continuous improvement and optimization are the foundations of our success. Our flawless execution program of lean methodologies and tools, such as 5S, Kaizen, and Six Sigma, is standard in every DB Schenker logistics operation and has been proven to improve efficiencies and lower costs. DB Schenker experts embrace and emulate our customers' business philosophies, cultures, and measurements. Our implementation and IT experts realize replicable, cost-efficient solutions rapidly in nearly any location. Our standardized operation processes, methods, tools, and templates can be easily adapted to our customers' needs. With decades of experience with numerous customers, we are one of the best partners for all production logistics services worldwide, leading to less implementation time, best operational processes, and profitable solutions. And we get leaner every day.
Okay, hope this was from interest for you. Not again. Can we go one back? All right. So having this as our standard solution for the automotive industry, providing the OEM's production lines. I mean, the deliverables that we have to deliver to the OEMs are enabled by, process discipline, by IT, of course, and also quality. And we're not only that we develop or that we implement those this solution in dedicated sites, as you have seen it in the video. We have developed that solution also to make it applicable for shared environments. So we can also start in small environments for smaller volumes. It doesn't necessarily mean a mass production, and that really makes it unique, really scalable, and we can really rapidly implement such solutions with the same quality standard as you have seen it in the video. Very nice example of that. Can I show you some names? But what I would like to show you here, this is a development that we had a couple of years ago where we started feeding into a production line with only a couple of suppliers for a premium OEM or an OEM for premium cars, really close to small batch production. But business grew for the OEM, and he was able to add additional modules and models, and by doing that, we also expanded our business with that OEM and their suppliers based, on the standard that we have deployed in that specific site, which, by the way, is a multi-user warehouse, meaning serving several customers, not only automotive, but which is geared to fulfill the automotive standards. But coming back to China, what do we do also to connect China, especially for our European customers, is that we have also train solutions in place, especially for our customers that assemble in CKD fashion here in China. And we deploy that solution every time when air freight is not an option due to costs, but ocean freight is not an option due to time constraints. So we have a northern route to the northern part of China, but also we have a southern route. Yeah, and finally, what I also would like to show you a little bit is our footprint in China. So in total, we have over 90 facilities as such, looking just at contract logistics, meaning dedicated and shared warehouse environments. We are quite present here. You see it with the red dots. And speaking about automotive solutions, we're active in China with production supply solutions, spare parts, of course, and particularly tires as well. So I hope I have catched up some time. And this is the end of my presentation. Thank you.
Thanks very much, Mark, for sharing some of those experiences of DB Schenker globally, as well as what's happening there in China. And again, a big thank you to all of our panelists, because I thought they had some really interesting presentations. We don't have too much time left, and we're going to have a shortened coffee break after this, so that we can have some more time for the Q&A in the next session, because some of our speakers had to leave early. But I don't want to cut off yet. I would still like to give you the opportunity to ask some questions. We've had some technical insights, some strategic overviews. So if there's anybody from the audience who would like to pose a question whilst our panelist is here, please feel free to do so. If not, I'll start. I have a few. If I can start with Paulina at Qoros. With the kitting approach, obviously you're doing that, as you mentioned, to be able to deal with the variation and the launch cadence you have right now. Do you envision that that's going to sustain at 100% or 90+% kitting or whatever you might have as you grow in capacity or in production at least? Because obviously kitting can be space hungry in some areas. So I mean, will you need external warehouses to do that? What's the sort of longer term view going out?
Already long-term view, kitting is the main strategy. We actually go the other way around. We don't see any possibilities to decrease. Since the launch of the production, we had only one part that we removed from kitting into sequencing because of more than 60 variants of that part, which took extreme amount of space. It was a very big bulk part. So only one went down. On the other hand, we introduced kitting in paint shop as well. And in the next year, we also plan to introduce it in body shop as well. So we actually go the other way around. And you know Mike very well. The direction is very clear. So we keep very strong towards the strategy. We don't back down. We don't go the easy way. We force this down the way and along the way, and we see a lot of benefit from doing it.
Okay, interesting. A question from my side to Mr. Louis. Because your organization is doing research and design across FAW, Volkswagen, FAW, Toyota plants, are you able to share the learnings and the sort of strategic outcomes of some of those projects or research across your joint venture companies or other FAW plants, or is it quite protected and firewalled between the companies? If you understand my question.
In designing, we do this. We think we have very good strategic partnership with the JVs. So regarding initial plans, we do it together. For example, it's a brand new plan. For example, you are going to set up you have a model plant. We go and visit the model plant, and we we refer the model plant good points to your Chinese new plant, and we discuss together a engineering plan. For example, in the Chengdu plant, for the Chengdu plant, for example, it's a new plant. If it's a new plant, then we can use the old model, but for brand new, you do not want to use the old model, you want to something new. Then we need discussion together with our customer to produce a better plan than the existing model in combination of the strong points and we also need to come up with some innovations. And we did this in Chengdu plant and I believe the customer believe that's a reasonable design and even better than their plant in Germany. And that's through thorough communication. So it's a joint product, I should like to say. Thank you.
Okay, an interesting, I think, example of how that joint venture structure can be some, can really share some ideas. Any other questions from the audience right now? I got perhaps one last, well, maybe not last, but for Mark. You showed the example of the Hanover plant where DB Schenker is doing the line feed and production logistics. I guess, are you doing any production logistics within China? So are you doing any in-house in-plant logistics, either in partnership with a company, or is it an area that you see more potential in, or you don't want to just comment on that?
There is more potential for us,
yeah.
Indeed. We do production supply services in the northern part of China, but still we see this is a market which is growing for us. I mean, it's growing per se, but what we can also strengthen our position here, especially in this field of activities. We have own infrastructure, so DB Schenker network of warehouses and employees. So we operate our warehouses by ourselves and not with partners.
And it's only because I know this from having spoken earlier with Paulina and Mike that Qoros has gone something of a different way with their own in-plant logistics. I wonder if maybe you just wanted to share a little of that experience, because I thought that was interesting that in contrast to many OEMs in China, you did not outsource this part.
No. Originally, we started as ourselves, and the first actions and activities in that area were focused on searching for partnership, and both on the design and the details, as well as later operation. Unfortunately, that didn't end in collaboration with a 3PL. We are still searching, but we have a very specific vision on the supply chain and very specific ideas on our processes and how we want to operate. And that's why we take time to find the right partner who actually shares the vision and will follow what we have designed and put in place, rather than put standard operations, which then will just not match what is the rest of the supply chain about.
Okay, thank you for that. Unless the audience has any final questions, I think I'm going to thank the panel now and again for some really interesting and fascinating presentations and some discussion. So, a couple of things quickly before we break. Again, a reminder about those evaluation forms. Please do fill them out and get them to us for this next session. We're going to do a prize draw at the end of it. This next coffee break is only 15 minutes or a bit less. We're going to kick off again at 3:30. With the OEM and a VIP panel Q&A. So please join us again, go out, have a coffee, and we'll have everybody back in this room. So see you in 15 minutes.